Hello students. Today we will see one of the most basic topics of chemistry. As you already know, chemistry is the study of the transformation of matter from one form to the other. These transformations often occur because of the combination of two different types of matter. Certain basic rules govern the combination of different elements to form compounds. These rules are referred to as laws of chemical combination. There are 6 basic laws of chemical combination that govern the chemical combinations of elements. Law of conservation of mass. Law of constant proportion. Law of multiple proportions. Gay-Lussac's law of combining gases. Avogadro's law. Law of reciprocal proportion. First, we must see the law of conservation of mass. According to this, in simple terms, this law states that matter can neither be created nor destroyed. The total mass, that is, the sum of the mass of reacting mixture, and the products formed remains constant. Anton Lavoisier gave this law in the year 1789, based on the data he obtained after carefully studying numerous combustion reactions. For example, CaCO3 on heating forms CaO plus CO2. If CaCO3 is taken in 20 grams, it forms 11.2 grams of CaO. Then the amount of CO2 formed will be obtained by applying the concept of the law of chemical combination. As the mass of CaCO3 is 20 grams, it implies the mass of CO2 will be the total mass of product formed minus mass of CaO, which is equal to 20 minus 11.2 is equal to 8.8 grams. Next is the law of constant proportion or definite proportion. Joseph Proust, a French chemist, stated that the proportion of elements by weight in each compound will always remain the same. In simple terms, we can say that irrespective of its source, origin, or its quantity, the percent composition of elements by weight in each compound will always remain the same. For example, CO2. Here the atomic mass of carbon is 12U, and that of oxygen is 16U. As there are two oxygen atoms, the total mass is 32U. The ratio of C and O to form CO2 will be 12 to 32, means 3:8. Similarly, for H2O, here atomic mass of hydrogen is 1 AMU. The mass of H in this compound is 2 into 1, that is 2 units. The atomic mass of oxygen is 16U. So the ratio at which the H and O will combine to give water is 1 to 8. After this, we need to see the law of multiple proportions. This law states that if two elements combine to form more than one compound, the masses of these elements in the reaction are in the ratio of small whole numbers. This law was given by Dalton in the year 1803. For example, let us see the various oxides of nitrogen. Nitrogen forms 5 types of oxides, which are N2O, NO, N2O3, NO2 and N2O5. In these compounds, the masses of N and O are respectively. In N2O, nitrogen 28 and oxygen 16, while in NO, N14 and O16. Next, in N2O3, N28 and O48, while in NO2, N is 14 and O32. Finally, in N2O5, N is in 28, while O is in 80. Now, if the mass of N is fixed at 14, then with respect to this mass, the O mass in the following compounds will be 8, 16, 24, 32, and 40, respectively. Thus, if we take the simple ratio of the O atom in all these compounds, then it will be 1:2, 3:4, 1:5. Next is Gay-Lussac's law. In 1808, Gay-Lussac gave this law based on their observations. This law states that when gases are produced or they combine in a chemical reaction, they do so in a simple ratio by volume, given that all the gases are at the same temperature and pressure. It is not applicable if only 1. The gaseous term is present in the reaction, like CaCO3 solid gives CaO solid and CO2 gas. While in the case of hydrogen and chlorine, gases react with each other to form 2HCl. This can be written as 1 volume of H2 and Cl2 each reacts with each other to form 2 volumes of HCl gas. Next is Avogadro's law. Avogadro proposed this law in the year 1811. It stated that under the same temperature and pressure conditions, an equal volume of all the gases contains an equal number of molecules. For example, at 0 degrees Celsius and 1 atmospheric pressure, if we take nitrogen gas, CO2, and neon gas, then if all these gases occupy 22.4 liters of space, they will all contain 6.022 into 10 to the power 23 number of particles in them. Last is the law of reciprocal proportions, proposed by Jeremias Richer in 1792. It states that if two different elements combine separately with the same weight of a third element, the ratio of the masses in which they do so are either the same or a simple multiple of the mass ratio in which they combine. For example, CO and H are taken. C combines with H to form CH4, and with O, it forms CO2. Now, H and O together form H2O. Now, if C is kept as a constant element, and the ratio of O and H is seen in these compounds, the ratio of oxygen in CO2 and H2O will be 2:1. Similarly, that of H will be 2:1. As we reach the end of the module, let us summarize. First, we saw the law of conservation of mass. According to this, the law states that matter can neither be created nor destroyed. Next is the law of constant proportion or definite proportion, which states that the proportion of elements by weight in each compound will always remain the same. After this, we need to see the law of multiple proportions. This law states that if two elements combine to form more than one compound, the masses of these elements are in the ratio of small whole numbers. Next is Gay-Lussac's law. This law states that when gases are produced or combined in a chemical reaction, they do so in a simple ratio by volume, given that all the gases are at the same temperature and pressure. Next is Avogadro's law, which states that under the same conditions of temperature and pressure, an equal volume of all the gases contains an equal number of molecules. Last is the law of reciprocal proportions. It states that if two different elements combine separately with the same weight of a third element, the ratio of the masses in which they do so are either the same or a simple multiple of the mass ratio in which they combine.